Welcome to Learning Styles and Lecture Development. I'm Joe Garman, and I will share with you some of the things I've learned about teaching, especially when it comes to learning styles. The objectives for this lecture are: first, determine your own learning style using the selected tools below. Compare and contrast the various learning style inventories, and consider the implications of students' various learning styles and what strategies can be employed. There are 5 websites here. The first one is Myers-Briggs. The next 2 are a visual, auditory, kinesthetic inventory. The 4th one attempts to combine Myers-Briggs and the VAK, and you can evaluate how well or how poorly it does that. And the last one shares some learning strategies around these various things. First, a little bit about my background. As you probably recognize from the voice, I teach pathophysiology. I currently teach pathophysiology on campus at Georgetown. I teach all of the nursing students, the traditional undergrads, the second degree students, the nurse anesthesia students, and the nurse practitioner students. I teach both undergrad and graduate pathophysiology. And again, as you probably remember, I taught numerous lectures on in the online pathophysiology course. My background is a little bit different than most of your faculty. I'm not a nurse, and in fact my undergraduate degree is in physics. I minored in electrical engineering, math, computer science, etc., etc. All those super techie things. I worked as a computer programmer for 20 years. And then at the age of 42, I went back to school and got a master's degree in physiology. I took a special Master's of Physiology program at Georgetown, which included many of the first-year med school courses. After completing the master's program, I continued with the PhD, earning a PhD in physiology. While I was in the PhD program, I took most of the second-year med school courses. So I have most of the preclinical education of an MD, but I have no clinical experience. Most of my classmates from the physiology program, the master's program, are actually now MDs. While I was an undergraduate, I spent much of my time tutoring and teaching. As an undergraduate, is math, physics, engineering, etc., those type courses. During the PhD program, I mostly tutored and taught physiology. I taught physiology to med students, nursing students, and other physiology students. I spent a lot of time during the PhD program working with at-risk med students. So at-risk med students are med students that are really struggling. And in med school, it's very hard to fail out. They'll keep working with you again and again and again. And I spent a lot of time tutoring these students, and they really helped me. They helped me perfect my craft. I really learned both physiology and how to teach it. I had to know this stuff so well that I could answer the most basic and inane questions at the same time. They also gave me insight into struggling students. Most of the students I've taught throughout my life, basically, I teach them something, I explain it to them, maybe work a couple examples, maybe answer some test questions. The light bulb goes off, the student gets it, we move on to the next thing. Okay? This is probably the experience that most of you have had. Somebody explains it, you get it, you move on. Maybe it takes a while, maybe it takes a short period of time, but eventually you get it. The at-risk med students were different. They just were not getting it. There were things that I would explain over and over and over, and they simply would not understand it. This was new for me, that is, and it gave me insight into how students struggle with various materials. They also gave me the incentive to learn lots of Plan Bs. Typically, I would explain something in a straightforward manner, exactly as it is. Student would get it, we'd move on. With these struggling at-risk med students, that wasn't working. So I would have to come up with another way to explain it, a different way, and then a different way, and then a different way, until finally the light bulb went off. So if you remember some of the pathophys lectures that I gave, you either had the benefit or the burden of all these Plan Bs. So I would explain the same thing multiple different ways. Now, in live lecture, I usually don't have time for that, but in the recorded lectures, since I wasn't getting any visual feedback from the audience, and I didn't know who was getting it and who still was lost, I would give all the possible explanations I could think of. If you needed all of them, great. If you didn't, well, hopefully it still wasn't too painful. So that's my teaching experience. I've been teaching pretty much all my life. Started tutoring back in junior high, and I have taught thousands of students. So hopefully I'll share some of my experience and you'll learn, gain some insight from it. And then here's a picture of me and one of my pet rabbits, Kaneen. Alright, so let's talk about Myers-Briggs. Myers-Briggs is a personality profile. And I actually attended a very interesting lecture the first week. In fact, I think it was like the second day of classes when I was taking physiology med student classes. A professor from University of Texas Med School came and told us some things about how to do well in med school classes. And his backstory was that he was responsible for the at-risk students at his med school. And being a scientist, he was a biochemist, he was looking for the pattern. What explained who became at risk and who didn't? So he looked at the obvious things. Was it age? Well, no, the old students, the young students, they were equally likely to struggle, equally likely to succeed. Was it male or female? No, male, female, equally likely to succeed, equally likely to struggle. Minority students? No, they were no more at risk, no less at risk. Even GPAs and MCAT scores didn't quite explain it, undergraduate GPAs. So finally one day one of his colleagues said, "Hey, have you tried Myers-Briggs?" And his immediate reaction was, "Myers-Briggs? That's the stuff they use over there in the humanities. We're scientists." But nothing else was working, so he tried Myers-Briggs. And he did Myers-Briggs assessment of all the med students and then specifically his at-risk students, and he found a very interesting pattern, which I'll explain in a second. But first a review of Myers-Briggs. So Myers-Briggs has 4 dichotomous parameters: extrovert, introvert, sensing, intuitive, thinking, feeling, and judging and perceiving. We'll talk about these in a little bit. Most of you should be familiar with Myers-Briggs. So when our University of Texas professor, John Paley, looked at his students and looked at all of the students and compared first year scores to second year scores and put down dots for each of the 16 Myers-Briggs profiles, he saw an interesting pattern. There were a couple points up here at the top doing very well. And those were INTs. INTJs did a little bit better, INTPs did a little bit worse, but the INTs were really doing well. The INTs are introverted. They can spend lots of time alone studying, which is very beneficial. They're intuitive, so they can take a few facts and put them together in new ways. They're thinking. They're very rational. Well, intuitive thinkers are really going to do well in very mechanistic preclinical med school courses, and the introverts are going to be able to study for longer periods of time than the extroverts. The J, judging, I think judging is actually a very bad name for this. I like to think of this as just do it. The J's are very good at time management. They get things done. P's, perceiving, I think that's also a bit of a misnomer. I think of P's as procrastinators. These people are really good at putting stuff off. The J's do a little bit better because they're better time management. The procrastinators, they still do okay because they're INTs. There is another group down here at the very bottom. And if the INTs are doing well, not surprisingly, the ESFs are really struggling. What he found was his at-risk students were almost all ESFs. Extroverted, they really would much rather be out partying than studying. They were sensing. They knew what they experienced, what they saw, what they heard, what they tasted or smelt or touched. They were observant. They knew the world from what they observed. They were not very good at taking individual factoids and putting them together. They were not intuitives. They were feeling. They were not rational, but rather emotional. Well, you can see how ESFs, extroverted, sensing, feeling people, are not going to be in their element in very mechanistic med school classes. Now, at this point in the lecture, I'm thinking, I'm clearly an INT. I'm a very extreme INT, and I'm thinking, INTs, we kick butt. Then he showed some more data. This is clinical performance. So as most of you, I'm sure, know, first 2 years of med school are all in the classroom. 95% of the grade comes from multiple choice tests. Third and fourth year are in the clinical setting, and 95% of the grade comes from residents and attendings giving their personal opinion of how you're doing or how the student's doing. So in third and fourth year, again, we see two groups, two Myers-Briggs groups way out there in the upper right, doing great. They're having a ball. They're excelling at all these rotations. It's the ESFs this time. The ESFs, the extroverted sensing feeling people, are doing great in the clinical environment. They were struggling in the classroom, but in the clinical setting they did fine. And if we think about this again for a second, the extroverts are going to be much better dealing with people. The sensing people, the observant people, are going to be much better at remembering what they saw yesterday. What were the drug doses? How was this procedure done? How did the patient look? Etc., etc. The feeling people were much better at the emotional aspect of the clinical world. And in the clinical world, as many of you know, how people feel about things is a very large part of the job. Not just are they in pain or are they comfortable, but are they anxious? Are they relieved? Dealing with families that are stressed out. The feeling person is going to be much better at reading the body language, reading the emotional state of the family. Not only that, but their coworkers, the other med students, the nursing staff, the physicians, all those people. The feeling people are going to be much warmer and fuzzier. The thinking people are going to be cold and rational. And, not surprisingly, the INTs who did great in the classroom are now having a bit of a problem in the clinical setting. So this was actually very insightful for me. Again, as an extreme INT, I didn't appreciate the ESFs. Now, also, you remember I told you I have no clinical experience. I don't want to work in a clinical setting. As an INT, I would clearly be one of those people that did great in the classroom and struggle in the clinical setting. I'm going to leave the clinical setting to the ESFs. Now, as a teacher and as an INT, I'm going to work as hard as I can to make sure that the ESFs in my classroom do okay, so that they can get to the clinical setting where they really excel. So this is Myers-Briggs. We have different personalities. Should point out here for a second, INTs, we make up about 5% of the U.S. population, but we make up about 95% of university faculty. Kind of makes sense. INTs are very good at things like research. Whether it's research in physics or whether it's research in history, INTs are very good at digging into facts and putting things together in new and novel ways. So not surprisingly, we end up in PhD programs, we end up getting PhDs, we end up teaching at universities. As a result, classrooms at the university level are usually run by INTs. This could also explain why, ESFs quite often struggle in a classroom setting and can't wait to get out of class and do something fun and useful. Meanwhile, let's move on to learning styles. So learning styles are actually a bit different than Myers-Briggs. So typical learning styles involve visual, auditory, and kinesthetic. So you can be a visual person, or you can be an auditory person, or you can be a kinesthetic person. And some people put reading in there. And I have reading in parentheses, and we'll talk about reading specifically later. Now, learning styles are different than Myers-Briggs. You can be a visual INT, you can be a visual ESF. You can be an auditory INT, you can be an auditory ESF. They're unrelated to each other. But let's think about this for a second. Visual, so why do I have a little cartoon drawing of a brain here? Well, primary visual cortex. That's where we get visual information. Auditory. Hey, there's our auditory context. That's where we get auditory information. When you hear something with your ear, the signal travels down, remember that 8th cranial nerve, going to the primary auditory cortex, right here where we're pointing. And finally, somatosensory cortex. That's where we get kinesthetic. Touch and proprioception all end up going to the primary somatosensory cortex. So look at that. Learning styles, our 3 learning styles correspond to our 3 big senses: vision, hearing, and touch and proprioception. So learning styles actually have to do with how we get information. Now, I should also point out that unless you're blind or deaf or have some serious CNS lesion, all of us have a visual pathway, we have an auditory pathway, and we have a somatosensory pathway. We all get information through all 3 pathways. The learning style just looks for which one do you have a preference for. Now, you should also notice that, you probably learned in grade school that we have 5 senses: vision, hearing, touch, and what are the other 2? Taste and smell. Those are down here in the gustatory cortex. Why are those not included in learning styles? Well, the only reason I can think of is, I don't know about you, but I've never used taste or smell in my classroom as teaching aids. Not because they're not useful. In fact, the gustatory cortex is more tightly connected to memory than any of the other 3, vision, auditory, or somatosensory. The problem is that we don't use taste and smell in the classroom because it's kind of awkward as an educational tool. If, however, you're, say, at a culinary school, then they would definitely use it. Or in the hospital setting, there are lots of smells, hopefully not too many tastes, but lots of smells that are clearly connected to learning. But in a classroom, we don't use those, and so they're not typically used as part of our learning style. All right, let's talk about reading for a second. So here's the angular gyrus, the verbal association area. It's in yellow. This is not one of our primary senses. So remember those questions, which of the following does not belong in a set? Well, in visual, auditory, reading, and kinesthetic, the one that does not belong in a set is reading. Reading is not a primary sense. Reading is not a way we get information. We'll talk more about this in a little bit, but reading is different than the other 3 pathways. All right, we got one more thing I want to talk about, and that's the volitional association area out here in the frontal lobe, or the prefrontal cortex. This is where the Myers-Briggs personality profile would relate. Remember, it's a personality profile. It's not a sensory pathway profile. So the learning styles and the Myers-Briggs personality profile are referencing completely different parts of the brain. All right, so having just gone through those learning styles, I'm now going to tell you why learning styles are useless. There's lots of ballyhoo about learning styles, but they're really, at the end of the day, completely useless. There is no neuroscience evidence behind these learning styles. And again, unless you're blind, deaf, or have a serious CNS lesion that leaves you paralyzed, we all use all 3 pathways. So how can I demonstrate how these are useless? Well, here's an example question used to determine learning styles. And when you do your own learning styles, you'll run across this question. When you study for a test, would you rather A, read notes, read headings in a book, and look at diagrams and illustrations? B, have someone ask you questions or repeat facts silently to yourself? Or C, write things out on index cards and make models or diagrams? Now think about this for a second. I hope you're having difficulty answering this question, because in fact, you should do all of these, with the possible exception of making flashcards. Some people are flashcard people, some people never make flashcards. But everything else on this list are things you should do. Different people will do them to different extents. Same person will do these at different times during the course. So, in the beginning of the course, you might be reading headings in a book, while the night before the test, you might be doing a quiz session with your study buddy. Or maybe you do it the other way around. Maybe you start quizzing with your study buddy, and at the end, right before the test, maybe you're going through and reading headings in the book just to refresh your memory. Different people are going to do these at different times, but all of these are things that you should do. You'd better do all of these if you want to do well in a course of any significance. So consider, for instance, pathophysiology. A lot of content. You've got to get that content in a fairly timely manner. A lot of stuff to learn, a lot of stuff to organize. You want to use all of your pathways. You want to use vision with diagrams and illustrations and graphs, and you want to use auditory by listening to the lectures, repeating things, making up stories. Maybe you want to do kinesthetics by acting things out. Okay. So all of us will use all of these. If you have one student in your class, you have all learning styles present. You have visual, you have auditory, and you have kinesthetic. All of those in every one of your students. So focusing on one learning style is useless. Focus on all the learning styles. So how can you use learning styles effectively? So the way to actually use them is not to worry about the learning styles of your students. Again, if you have one student, you have all learning styles present. Instead, what you want to do is you want to learn your learning style. And if you are extreme visual or extreme auditory, or maybe an extreme reading person, you want to teach to the other learning styles. So if you're a visual person, teach to the auditory people. Make up more stories. If you're an auditory learner, teach to the visual people. Use more pictures. Okay. Always play to your weakness. You don't have to worry about teaching to your strengths. You'll do that naturally. But teach to the other students. Again, don't worry about your students' learning style. Your learning style is the important one. So a quick word about learning styles versus thinking styles versus intelligence. So Myers-Briggs, as I mentioned, is a personality profile. The visual, auditory, kinesthetic is a learning style. These two have been conflated and confused for so long that people can't separate them. Learning styles have to do with how we get information. Visual, auditory, kinesthetic. Thinking style are more like the Myers-Briggs personality profile. This is how we use information once we've gotten it. These are different. Again, you can have a visual INT, you can have an auditory INT, you can have a visual ESF, you can have an auditory ESF. They're not the same thing. They are different, and don't confuse them. The other thing to keep in mind is intelligence. The personality profile and the learning styles do not assess intelligence. Assessing intelligence, of course, is kind of politically incorrect, and yet we do it all the time in classes. So keep in mind that just because somebody's an INT doesn't mean they're smart. Doesn't mean they're stupid. Just because somebody's an ESF doesn't mean they're smart or stupid. You can have a smart INT, you can have a stupid INT. You can have a smart ESF, you can have a stupid ESF. And I'm sure you can think of examples in your life or workplace of all of those. Smart INTs and stupid INTs, smart ESFs and stupid ESFs. Okay? And I know stupid is a politically incorrect word, but we all know what we mean when we say it. So learning styles, thinking styles, and intelligence, these are all different, and people can have different profiles in each of them. So putting all this together, how do you construct a good lecture? So a couple things to keep in mind. The first is you are you and not anyone else. Again, know your learning style, know your personality profile, teach to the opposite. So I'm a visual INT. If I teach to visual INTs, the visual INTs in the classroom are going to love a lecture. Everybody else is going to hate it. So know who you are and teach to the other people. Also, take feedback. If students like something, great. If they don't like it, try to fix it. Keeping in mind that they're also giving only their perspective. So if one student doesn't like something but 99 students do, try to change it to help that one student without losing the other 99 students. Play to everyone's strengths. everyone that you teach, especially if they're nurses, are going to be visual, they're going to be auditory, and they're going to be kinesthetic. They're going to have all of those. So, at least in the classroom setting, visual and auditory. If you have lectures that use both visual and auditory methods, you will play to everyone's strength. The visual people will like it, the auditory people will like it. You won't leave anybody out. And if you can throw some kinesthetics in the classroom, even better. Now, in a clinical setting, you'll have a lot more kinesthetic stuff. Anything that involves manual manipulation of stuff, placing central lines, IVs, bed baths, whatever. All of those are going to be kinesthetic, and so there you'll have much more opportunity for kinesthetic methods. Conjure an image. So again, for the ESFs only know what they've actually seen or felt or heard. So if you go into some abstract topic that an ESF has no connection to, you lost him. ESF is clueless. If instead you can conjure an image, take something that the person has experience with, and get that in their mind, and then manipulate that image slowly into what the abstract thing you're discussing, then the ESFs will be kept along, will be included. Meanwhile, of course, the INTs will be perfectly happy to do that. INTs like images as well as the next person. So engage your students by conjuring an image in their minds and then working with that image. Inspire your students. So at the most basic, teaching is sharing information. But at the highest level, teaching is really inspiring. And whether your students are other nurses in the hospital setting or whether you're doing patient education, you want to inspire your students to take the information you're giving them and apply it in some useful and constructive way. So those are all the things you can do, and even if you don't do those, at least don't annoy them too much. So what do I mean by that? You've probably all had lectures that you found really annoying. Yeah. So think about an annoying lecture. Think about a couple annoying lectures. What do they have in common? What they have in common is that they probably, depending upon your particular learning style, they probably used the other learning style to the extreme. So a good example would be the person who has the reading learning style and has a big block of bullet-pointed text and reads the text. An example of that would be my teaching experience, the second slide. A lot of text. I didn't quite just read it straight because that would be even too mind-numbing even for me. But I just went through the text. Blah, 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 blah. Boring slide. I would not do that except for illustration. And you're not going to be tested on any of my background experience, so you can ignore that slide. That's an example of too much verbiage. The reading people, happy. Everybody else, bored, senseless. The heavily bullet-pointed reading slide is also intellectually lazy. It's lazy for the teacher, it's lazy for the student. The teacher just says, here are 7 bullet points I want you to know, just learn them. The student doesn't have to use any thought process, just has to memorize those 7 bullet points. This almost takes the teaching out of the information conveyance. So that's an example of a bad slide. About 90% of people hate slides that are all text and the instructor just reading them. The other 10% are clearly the reading people. Another example of a bad slide would be the learning style slide. That was the picture of the brain. That appeals to the visual people. So, visual person, picture of the brain, great, I got it. There really wasn't too much of a story going along with that. I just mentioned some of the parts of the brain and how senses relate to the learning styles. Not a lot of content there. The visual people would be okay. Everybody else would be kind of like, yeah, this is boring. An example of a slide that's somewhere in between would be the Myers-Briggs personality profile. That slide had a lot of content. There was a lot going on, but by using both a story and what I think are good graphics, the graphs with the circles and the arrows and blah, 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 the visual people are engaged, the auditory people are engaged because the story's going along, and so that's one that actually fits both learning styles. And even though there's a lot of content on that Myers-Briggs personality profile slide, most people will be able to follow that slide fairly well. So at least don't annoy them. Don't have the text-laden slide and just read it, or have just a picture and no story to go along with it. So again, pictures and words. If you have visuals and stories at the same time, you're appealing to more brain power. All of us have visual pathways. We all have the auditory pathways. Use them. We can use them both at the same time. Farming out tasks to separate pathways buys more processing power. We can look at pictures and hear stories about the pictures at the same time. It's not overloading us. On the other hand, if we're reading while somebody's talking to us, we're not paying attention to them. Okay, that's an important point. Reading is not visual. Just because we're getting the words off the page using our eyes is not going through our normal visual processing. And we can't listen and read at the same time without being distracted. Alright, so what's an example of a good lecture? So hopefully this doesn't set you off into bouts of PTSD. But this is a lecture that I think is actually fairly good, or a slide that I think is fairly good, that demonstrates a couple points. So I'm a visual INT, fairly extreme visual, fairly extreme INT. Again, most college professors are INTs. In the sciences, most people are visual. So not surprisingly, most med school preclinical classes are taught by visual INTs. And they're taught to visual INTs. I did quite well in those classes. They were easy for me. Basically, a lecture would be, here's a slide, here's a picture. The professor would say, here's a picture, isn't it pretty? Let's move on to the next one. As a visual INT, that was all I needed. The ESFs and the auditory people in the room were losing it. So when I started making lectures, I would have something like this picture on the left, components of a nephron, and I just have that diagram. And I would talk about the diagram, making ultrafiltrate, reabsorbing, blah, 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 blah. My auditory ESFs weren't too happy about this. So I added a few things. The story about taking the trash to the cleaning your house or apartment by moving everything to the street corner, and then taking back what you want to keep. Hopefully you all remember that story. That would conjure an image in the minds of the students. So it would engage the auditory people, it would engage the ESFs. And obviously the auditory ESFs were engaged. I now had an image, the taking the stuff to the street corner. I could now relate that to the making of the ultrafiltrate. The ultrafiltrate has everything in our blood except for the platelets and red blood cells and white blood cells, etc., and proteins. And now we want to take back the stuff we want to keep. So by having a story, I've conjured an image and I've engaged the auditory people. I now can go through this diagram. I haven't lost the audience yet, and now I can start converting that image into the actual function of the nephron. I then later added the glomerulus to this picture. The glomerulus was on a separate slide. By putting it here, I can now relate to it in position. And so it's easier for me to talk about the glomerulus when we're making the ultrafiltrate, and then to get back to it when we get to the macula densa. Meanwhile, I got a few words here. Not so many that people are going to get annoyed, but enough words here that the verbal people can follow along. Additionally, there are a few things here that I will point out to the ESFs. So in the diagram we have proximal tubule. In the outline I have proximal convoluted tubule. Most people are not going to have a problem. They're going to see that these are the same. But the extreme ESFs are not going to realize that proximal tubule and proximal convoluted tubule are the same thing unless I spell it out. So I will spell out that proximal convoluted tubule and proximal tubule are the same thing. Likewise, when I get to loop of Henle, thick descending limb, thin descending limb, I will point to them, not expecting the student, again the extreme ESF, to realize that the thick one is thick and the thin one is thin. It sounds kind of silly, but the extreme ESFs only know what they've observed or what they've been told. I can't expect them to make these connections. Now, I don't see this as a particular problem because, again, the extreme ESFs are going to, again, assuming that they're intelligent ESFs, are going to do quite well in a clinical setting. If they're dumb ESFs, well, that's another story. All right, so I started with just the picture. I added the glomerulus, I added the words, I added a story, and now I have a slide that contains an enormous amount of information. I mean, I go all the way through the nephron explaining all the parts and their functions. This slide usually takes somewhere between about 5 and 10 minutes to go through, and when we finish this slide, we have finished about 70% of the kidney. And yet, it's a slide that works for most students by having both the visual and the auditory. Alright, so let's wrap this up. So what does it mean to teach? So first, a quick little story that I think is kind of fun and funny. A couple years ago I discovered a site, ratemyprofessor.com, and being a data-driven INT, I thought, wow, I can really use this. I can make all kinds of interesting observations. So what I did is I went through Georgetown, I looked at every department in Georgetown, and I looked at the best professors in each department at Georgetown, looking for the best professors at Georgetown. And my goal was to actually go attend classes, to sit in a lecture from each of these, or from many of them, and to see what do the best rated professors do. Why are they well liked by their students? So I made my list. I went out, I met the teachers, obviously asked for permission to sit in on a class. I sat in on about a half dozen classes or so in a wide range of subjects, from neuroscience to religion, computer science to history. And so the subjects were very different. And yet I found a couple common patterns. The first is know your subject. There's absolutely no substitute for knowing the material that you're going to teach. Now, you have to know it well enough so that you can explain it to the students clearly. If you're fuzzy about something, your explanation is going to be fuzzy, and you're just going to confuse your students. So there's no substitution for knowing your subject. Second, be passionate about it. Now, students like to complain about professors who think that their subject is the most important in the world, but students complain a lot more about professors that are bored by their subject. Okay. If you're bored by your subject, you're not going to convey any enthusiasm for it. So know your subject and be passionate about it. And third, care about your students. So care about your students, both appreciating the passion that you feel for your subject. So you want your subjects to really be excited about whatever it is. So if I'm teaching pathophysiology, I want my students to be as excited about pathophysiology as I am. Now, in the case of nursing students or pre-med students, this is actually pretty reasonable because this is going to be an important part of what you do. But still, I want to care that you care about it. Second, not only care about the students learning material, but care about the students themselves. So while I think pathophys is the most important subject that you're studying, I also appreciate that you have other subjects that you're learning, and that I can't expect to occupy all of your study time. You have to have a little bit of study time left over for your other classes. So know your subject, be passionate about it, and care about your students. That's what I learned from my Great Teacher project. A few other things. So teaching at its most basic is informing, just sharing information with somebody else. But that's at the most basic. Teaching is also about persuading people. And if you're teaching in the clinical setting to other nurses, quite often you're going to be persuading them to change a protocol that they've been doing for years. In order to persuade them to change, you have to be persuaded that the new protocol is actually better. If you're not convinced, you're not going to convince any of them. So if you're not convinced, figure out what you need to learn in order to be convinced. And finally, at its highest, teaching is about inspiring. So again, whether it's students, whether it's nurses that you're teaching, or whether it's patient education, or whether it's nursing students that you'll be teaching in a university setting, you want to inspire your students to apply that information far beyond just knowing it. Alright, so let's wrap this up. Teaching is fun. I really enjoy teaching. I hope that you're taking this class because you enjoy teaching and that you're going to enjoy it for a long time. Teaching is important. And finally, you're in control. When you're teaching, you are the master of the classroom. You know the material. You know what students are going to struggle with. So meet your students where they are. Whether they're INTs or ESFs, whether they're visual or auditory, meet them at their level of intelligence, meet them at their level of experience. If you're doing patient education to somebody who's never even heard the term diabetes mellitus, you're going to have to explain things at a very different level than, say, explaining the latest change in drug protocols regarding diabetes to a bunch of FNPs. Very different audience. Your teaching is going to be very different. You got to meet the students where they are. Alright, I hope you learned a few things. This is always longer than I want it to be, but I guess I just droll on longer and longer. Alright, good luck and have fun.